Welcome back to Naresh Vlog YouTube channel. I am Naresh and this is your favorite channel, Naresh Vlog YouTube channel. Nobel Prize is a thing or an award given to a scientist for extraordinary invention which makes the mankind very useful and productive and improve the life of a man. So, we have totally six fields. The first is medicine or physiology, physics, chemistry, economics, literature, and peace. So, this year and on this video specifically, we are going. So, this year we have got three scientists who got the Nobel Prize on chemistry. Important fact, and a Nobel Prize is 8.3 crore Indian rupees. So, the three people who found the quantum dots which won this year's chemistry Nobel Prize are Mohini G. Banvi, Lucy E. Bruce, and Alexei E. Imwoki. So, these three people found and discovered quantum dots and synthesized quantum dots. A special mention that these three people are from three different ages. So, first let's see what's quantum dot. Second, what's the phenomena in what this goes on, and each individual contribution. And last, is there a future perspective and current status? So, let's start. What's quantum dots? Quantum dots are the miniature size of anything. They are crystal and a quantum size of a crystal or a nanocrystal. Basically, quantum and nano are equally similar. So, their natural properties like atoms, molecules are the same, but there's a catch in it. When the size go down, the conductiveness, magnetic thing, and the conductivity things go down. More than that, the optical appearance or optical property goes down a lot. This is where they came to know that the more you cut down a gem, you get more difference in optical size. So, the larger the crystal is, the reddish in color the crystal. The lighter the crystal is, bluer in color the crystal. So, can most of you have a doubt? How does this come under chemistry and what's the use of this? Why did they get this Nobel Prize? So basically, now let's hear a theory that now let's go in more about the chemistry field and the discoveries and the phenomena behind it. So, the phenomena or the chemical property behind this is the particle in a box. Basically, it tells that E is equal to n square hat square by 8 ml square, which is basically that energy is inversely proportional to the wavelength of light. So, basically, this tells you that the more the space, more the reddish it comes. Lesser the space, more bluish it comes. This could be also defined that if I have a crystal which is bigger in size, so it looks red, and the crystal which is small will be in blue. This is basically the phenomena behind this discovery. Individual contributions of each scientist in this quantum dots. So, first scientist is Alexei I. Ikimovi. So, he was the first person to get a discovery of this quantum dots. So, he was a physicist who was doing his PhD in 1970s or 1980s, and he was going with semiconductors. Basically, at that time, they were using optical property for seeing its purity. So, Alexei had a specific time code, a specific pathway of finding the purity of a semiconductor. When suddenly he done an experiment where he melted the tinted glasses and added copper sulfate in it when it got cold and when it was in a normal state. When Alexei looked through it, he found that the places where copper sulfate was more, it was in reddish in color. The places where it was less, he found bluish in color. This made him to write an article and it was published publicly around late 1990s, and this was a great discovery, and but it was not proven. It was found in a robust manner. So the second Nobel winner comes into the play at this point of time. He was working at Bell Labs and he was in a mission to do chemical reactions out of solar power. At a certain point in his mind, it comes. Why not to do with a smaller amount of crystals which gives you larger space? When he cut it out with a knife or crystal, he got larger space and more than that, he discovered a thing that when the size of the crystal changed, a color changed. This gave him a great bloom. He was doing a great resource, but he could not cut that crystals into a uniform shape, which made a huge problem. The colors were inconsistent. Now comes in the third laureate, Muhini G. Bangwood. So let's call him Bangwood. So Bangwood was also in the lab of Bruce, Mr. Bruce, and he got an idea of synthesizing the crystals. When he got an opportunity and he became the MIT research head, he started this project. This was done successfully. You heard me right. This was done successfully after a decade of failures. First of all, they injected the liquid into a solvent very carefully. When temperatures were coming down, it formed a crystal. So, with the help of a needle, they reduced the temperatures faster, which made crystals in a consistent way, which gave a great bloom to a new form of chemistry called nanochemistry. You heard me right. It's nanochemistry. So these are the things found by these people. So at last we could say that when you have a smaller crystal, you get blue color, and when you have a great crystal, a bigger crystal, you have red color. So by this we say that quantum dots. Quantum is light and dot is the size. It's the light size which determines the color. So now let's discuss about their future and current market perspectives. So basically, quantum dots are about colors. When you go about colors, things which you hear are LEDs. So previously we were having LCDs, then we had LEDs, then OLED, Super AMOLED LED, Super AMOLED displays. Because synthesizing crystals are very tough, but with modern technology, we might soon be able to do it in a faster and effective manner. So this brings us into a conclusion.